All right, so I think it's time to get started. Good. All right, so hi everybody. My name is Ali. I work at Google, and I get to work on Node Core, and I'm a member of the Node Technical Steering Committee. And I also work on Google Cloud, and I get to make Google Cloud one of the best places to run Node applications. And today I'm going to talk to you about memory leaks. So I'm assuming you have some idea of what a memory leak is. If you don't, this is what it looks like. Memory up to the right. So if this was your stock, you'd be really, really happy. But yeah, that's a memory leak. This one is a slow one. You can see over several days something is leaking. So it's not a nice one. Sometimes they're really fast, and very soon your application just goes kaboom. And then bad things happen. And maybe your manager beats down your neck and says, fix this. All right, so let's just first dig a bit deeper into what a memory leak really is. And this is the definition that Wikipedia has, and I don't like it that much because it's confusing. Memory that is no longer needed is not released. But what does released mean? Because, well, we have garbage collection. We don't have to free memory ourselves anyway. So what gives? So the contract that garbage collection has with you is that anything that is actually garbage, stuff that you're not using, stuff that's not tied to the ground is garbage. And anything, yeah. Actually, I like this video because that mailbox was not garbage. Okay, so taking this metaphor and looking at your JavaScript objects, if you're holding on to a JavaScript object, and what do I mean by holding on to a JavaScript object? If you have an object that points to another object, the first object is holding on to the second one. If the first object is not garbage, the second one is not garbage. So if you have a global variable that has an object inside it, that object is not garbage. That's a contract GC has with you. And anything that's garbage, it will sweep away. So it's like having a Roomba, one of those robotic vacuum cleaners. You throw stuff on the ground, it will sweep it up. But if it's actually not on the ground, it can't sweep it up. All right, so how many people have actually had the opportunity to go debug a memory leak? Was it fun? Okay. So, I mean, it would be better if you don't write memory leaks to begin with. And I have 3 steps to do that. First, don't write code. Don't use code from anybody else. Yeah. Okay, I'm half joking. So I think it's important to understand what memory leaks are and how they manifest in your code. I think if the goal is never to have memory leaks, that's hard. I'm not saying it's impossible. It's very, very hard. And chances are the application you're running with Node, maybe a small part of it is code that you actually wrote. There's probably 5,000 NPM modules you're using that who knows who wrote. They may have memory leaks. And then there's other stuff that may have memory leaks. So I think what's more important is understanding why memory leaks happen. And even more important, being able to debug, having the tools that you have experience with that will let you debug those memory leaks. So I'll go through some examples. In this example, this is like a very simple Express request handler, the Hello World app you do with Express, but I am allocating a really big array inside this handler. And it's garbage because I never do anything with it. But this is not a memory leak. Why is it not a memory leak? Because GC can see that you're not using this anywhere. You're not holding on to this object that you've allocated. Right? There's nothing that would prevent it from being garbage collected. So you run this, it's not going to be fast for you to allocate this object unnecessarily, but it's not a memory leak. Okay, so better example. So I'm actually holding on to the garbage now. So I put the garbage in the request object, so this surely should leak memory, right? Actually, this isn't a memory leak either because you have to look at the request object when your request is done, it comes into Express. Express gives you information about this is what the user wanted, and you send a response back. And when Express knows that you're done with it, it throws away all references to the request object. So if the request object is garbage, anything that only it refers to is also garbage. If, on the other hand, if you've taken this array and stored it somewhere else as well, in addition to request.garbage, then it would be different. Then we'll have to look at where did you store it? Is that thing garbage or not? So this is still not quite a memory leak. All right, so the key insight, or one of the necessary conditions, is about expected lifetimes. Right? So when you have an object and you think this should only live for a short amount of time, so this is an object I've allocated, and I think it's short-lived. And then you go store it into an object that's really long-lived. Then that might be a memory leak. And another thing to note here is it's about expectations. Right? So that's why memory leaks become a bit fuzzy, because you're working with a bunch of APIs, and what was the contract you had with that API or that module that you're using? Whether if you give it an object, are they expecting it to be, like, is the contract that they're going to hold on to it for a really long time, or is the contract that they'll just use it and never keep a reference to it? So that's why it becomes tricky, right? That's why it's hard to avoid memory leaks, because you have to really understand how your objects are going to be used. Okay, so one more example. This is a bit contrived, but I wanted to actually show you a memory leak. This is most definitely a memory leak, because I have a module global map. So there's an object on the outside requests, and every time a single request comes into my server, I throw more stuff into that object. The outermost object is going to live forever, so now you're actually leaking all the requests that come in. So this will quickly run out of memory. So on my laptop, I can handle probably 15,000 requests per second in a simple Express server. So this is 15,000 requests will be leaked every second. So this will run out of memory really fast, which is good, because then you'll know right away that something is wrong. So, okay, so this is a slightly less contrived example. This is actually taken from Stack Overflow. So there's a memory leak in here. There might be some object allocations. There are some object allocations in here as well. The obvious one is the object literal that we have, content type JSON. That object is not leaking, right? Because that object is passed on to response.writehead, and we have a contract with that function that is not going to hold on to that after the request is done. What is actually leaking is actually the same problem as before. The client is a top-level object. Client.on, what is the contract of the on function? The contract of the on function, this is an event emitter, by the way, is that you give it a function closure. Closure is the right term, but you give it a function that you've defined in a line. That basically makes a closure. That's an allocation. And it may have storage associated with it. And the contract it has is that whenever you give me a function, I'll put it in a list. And whenever that particular event happens, I will call this function. So you're doing it every single time a request hits your server, right? So you're allocating a new closure every single time. This is going to leak memory as well. So this one looks like a typo. This code shouldn't be inside the request handler. Seems like it should have been at the top level. That's my guess. But yeah, so this would leak. All right, so now things are getting tricky. So this small program, you can run this in Node today. This program, the only thing it's doing is looking at how much memory it's consuming. It's doing nothing else. And this program will increase its memory footprint as you run it. It will run out of memory eventually. So this is not quite obvious, because I actually don't see an allocation right there, right? So and actually there's an asterisk on the leak. It's debatable whether this is a leak. This is a thing that JavaScript doesn't like anyway. So basically what happens here is that we're tying down the event loop. This is a synchronous loop, right? This is all going to run on the same tick. What console.log does underneath the covers is it's going to allocate some closures and say on the next tick, do something, right? But the next tick is never going to come. okay, actually it will eventually come, but after a very, very long time. So this will leak memory as well. So the thing is, functions that you call may leak memory, and you have to understand what they do. So this is an interesting example, but leaks can be totally unexpected. So take this code, run with the latest version of Node 8.x. By the way, don't panic. This is getting fixed really soon. In 8.7 on Tuesday, this will be fixed. And also, this is a very specialized condition that most likely is not happening in real apps. So this will leak memory, but not right away. It runs stably for about 2-3 minutes, and then it just goes like a hockey stick and leaks memory. So what's my point here? My point here is that the code you might have that's running correctly today might leak memory in the future because something else has changed, or the conditions under which your application is running change, that now you suddenly have a memory leak. So it's great to understand that object lifetimes, and when I have a long-lived object and I store a short-lived object inside it, that's a memory leak. But it's even more important to be able to debug memory leaks. All right, so for debugging memory leaks, let's talk about some of the tools that you have available. And so whenever I look at these tools, for Node, there's a few questions that I'm asking myself. What kind of leaks can it find? Can I use this in production? Because that's the thing I fear the most, right? Leaks that I can catch in development are usually the easier ones. The things that make it to production are usually the harder ones. And if a tool that I'm familiar with doesn't really work that well in production, that's a problem. So those are the questions I'm asking. And I'm actually going to focus more in this talk. I will cover native leaks and JavaScript leaks as well, but my main focus is JavaScript leaks, because I'm guessing most people are interested in JavaScript. Most people are writing JavaScript, and that's what you care most about. So first question, when you're leaking memory, where is it actually leaking? Actually, let me go back 2 slides. So in this case, this is actually quite ironic. This is a leak in the V8 garbage collector. So the garbage collector itself is leaking memory. So the problem was that the V8 garbage collector is quite awesome, actually. It is quite adaptive. It's trying to figure out what your app is doing, and it's coming up with the heuristic that this would give you the best performance for your garbage collector. We won't be interrupting we won't be incurring as much latency if you work this way. And there was a bug that existed in that heuristic, and that's why this leaked memory. So this is a native leak, right? This is not a JavaScript leak, but your application may still experience this. So that's what I mean by a native leak. And there's some tools available for debugging native leaks as well. And then, I mean, at the outermost level, the most basic level, you need to understand, I would guess you would have some monitoring in your production applications that basically is showing you a chart that basically shows how much memory you're actually consuming. So, or maybe it's just the top command you have on your Linux machine, or the task manager that just shows you memory usage. Those are the first set of tools to look at when your application is behaving weirdly. So if you are not going to use any other tools, this is the most basic thing that you can have. This has 0 dependencies. Okay, I'm lying, there's 1 dependency, but that's just for formatting numbers. So you don't need anything. You just put this in your application, and it will just keep spitting out how much memory it's actually consuming. And you can have a running takeoff what's actually happening in your application from a memory point of view. So this is nice. Actually, there's some modules. One is called memory usage by Thomas Watson right here. That actually is really nice. That actually plots it. So it makes it even nicer to use it. The challenge might be that one may not be as suitable to run in production because it opens a browser page and shows you the data. So this stuff is the most basic thing you could have that gives you an idea of how your application is behaving. So let me cover a few topics. Let me cover what this actually tells you. It tells you what the resident set size of your application is. The resident set size is how much RAM your application is consuming. This includes anything that V8 is using, This includes anything that Node core itself is using. It includes anything that any other library that Node uses, or any other native module that's running as part of your application. Or if the Postgres, for example, Postgres module that you're using, if it's allocating objects that are C++ objects, those would all be in the RSS. So if your RSS is going up, you probably have a memory leak. Actually, I should refine that and say if the residence set size is going up and you don't expect it to go up, that's when you're likely to have a memory leak. Heap total is the total amount of memory that you have available for JavaScript objects. The way the garbage collector works is that at any given time, you have some amount of JavaScript objects, but it grows eventually until it reaches the heap total. And at that time, it decides whether maybe it was too short a time in which I was able to deplete all allocated heap space. So maybe I need to grow the total heap size. So this is a really good metric of how much space GC thinks you need for JavaScript objects. So if you have a memory leak in JavaScript, you would probably see this number going up as well. Heap used is a bit more variable because it goes up and down as garbage collector works. So you can look at that as well, but heap total is probably a good enough metric to look at. And then there's external, which is interesting. So this is any memory that Node core is allocating for objects that it needs to connect between JavaScript and native side. So if you have, let's say, a buffer, this would go into the external memory. So V8 reports this as well. So this is interesting as well. And later on, I'll come back to how. So if your overall external memory is going up as well, that means maybe you're leaking a buffer or some other wrapper object that Node core is using. Yeah. OK. So now, let's say now you know that you have a memory leak. What are you going to do about it? So this tool, Heap Snapshots, has been available for a very long time. There's almost any memory leak tutorial that you look for on the internet for Node is probably going to talk about Heap Snapshots. So I'll give you a fairly fast overview of what this thing is. And then I'll move on to some brand new things that are now available. So I'll actually do a demo for this. So heap snapshots. So this is your Chrome DevTools. You can run node-inspect, and you can attach DevTools to it. And so basically, normally, you probably see interface like console or sources, but this is the memory tab. And you can actually take a heap snapshot of the current running application that you have. I'm not going to do that right now. I actually have taken a heap snapshot that I saved earlier. And the actually interesting thing is you can save these snapshots as files on disk, and then you can load them back up and you can view them. So I'll cover a few things that are being shown here. It's telling you right now all the objects that existed in the JavaScript heap, every single one of them, and what they look like, who was holding on to that object. Remember earlier I said that something is not garbage if something is holding on to them, right? So if you expected something to be garbage, this will tell you why that thing is, who's holding on to that thing, making it not garbage. So, and just looking at this, let me increase the font size once. So just looking at this, you can notice that there's lots of objects, and the constructor that allocated that object is the first column. And this is the number of objects of that constructor that exist. So looking at this, you can right away tell if there's a memory leak, and that's it, then this object thing looks very common. If I sort it by count, seems like something that's just an object literal is leaking. Shallow size is the amount of memory that specific object is, and retained size is all the memory that objects reachable from that object have. So let me drill down a little bit. So each of these entries is an individual object that existed on a JavaScript heap. Right? These are right now live in memory in your Node.js application. Now let's just look at one of them. So when you click on one of them, or expand them, this actually shows you what the object has. It's actually showing you the internals of the object. It has a map, it has the proto, and it has one property called URL. So And looking at some of these other objects in here, you can see most of these objects are this one. So right away, you know this is the leaking object. So can anybody tell me which object, like where the leak might be? Well, you know what the leaking object looks like. You don't know where in code this object was allocated. And if you're really familiar with your code, right, if you, just by looking at the object, it has a special property name that you know only one place in code adds, then you have a pretty good idea where the leak is. But that may not be the case in all cases. In this example, I have no idea. I have no idea where this object was allocated because map is huge and I didn't write all of it. And yeah, I know there's a leak and the leaking object looks like this, but I don't know where it is. In more real-world examples, you won't see such a stark contrast, right? So you won't see like this one object type is so predominantly common, right? You'll have lots of other object types. So what do you do in those cases? Well, there's a really nice comparison view. You can say, compare this log to this other log that I captured, let's say, 30 seconds later. And it actually tells you the delta. Like, we have this many fewer objects of this type and this many more objects of that type, right? So this can give you an idea of over time, this is what's increasing, right? So this gives you a better signal for what actually is maybe leaking if there's too much noise and not enough signal. All right, so let me also show you this retainers section. So let me click on an object. Let's go find one. Let's say this one. So it's telling me who's holding on to this object. So the output says object number 727539 has a property named chunk that is holding on to this object. Okay, who's holding on to chunk? Next. It just keeps on. So it looks like there's a linked list of next pointers that just is growing unboundedly. So you already are getting some hints about where the leak might be. Okay, so this is all good. This is what a heap snapshot is. Let me, and I have a summary slide right over here. There's a detailed tutorial that's linked over here, and I'll at the end I have some links to this to these slides, so you can actually find all the speaker notes as well. So you'll find all these links. So this is great, but it has the challenge might be that it tells you what the leaking object looks like, but it doesn't necessarily tell you where it might be. And there's some other practical considerations for production as well. So I showed you DevTools. It's fairly unlikely that you're going to attach a live debugger to your production server. Or if you're doing that, please think about it carefully because you can do damage to your production server. Other considerations, taking heap snapshots is expensive. We have to do a complete GC, and then we have to walk your entire heap and serialize all the objects that exist in the heap. So if you're doing this in production with live traffic, you might experience a latency spike when you actually take the snapshot. So you definitely don't want to be taking these snapshots like once every second because that probably won't even finish. There's a really nice module called heap dump that lets you take heap snapshots and writes them to disk. So and that would be a much better way of doing this in production, right? So install that module and maybe run it in an interval that every hour it takes a snapshot and writes it to disk. That may be a valid way of doing it, but be aware that you're going to witness that latency spike. So other consideration, there may be sensitive data. In fact, this is into your entire heap. Your customer data will be in here. So be careful who you share with this data with. Okay, so the next tool I'm going to show you is allocation timeline. So allocation timeline is right here. So it's actually pretty much the same thing as allocation snapshots. The difference is it basically takes a sequence of snapshots effectively. And the really good thing about it is actually you can focus on a really small part. It can give you a really good understanding of, in this small time interval, what was getting allocated. I'm not going to spend too much more time on this because this is nice, but the thing I really want to show you is there's a detailed tutorial linked here. So the thing that I really want to show you is something brand new, sampling heap profiler. This is new in, actually it has been there for a year. Very few people know about this. And this is what it looks like. It's the same profile that I showed you before, but same app, same memory leak. But if anybody's familiar with CPU profiler, it's very similar to that. It's telling you these functions are allocating memory. And the width of the bar chart, width of the chart tells you how much memory they're allocating. So it is built for production. It has very low overhead, and it's based on sampling. So at any given time, what it does is these are the objects that are live on the heap, and this is the function that allocated them. So in this case, you can actually right away tell that the biggest bar in here is app.get. So you can actually see the call stack. And this pinpoints to you exactly which function was it that actually allocated the memory. So I think this is great. And the reason this is great is because I implemented them. So this. All right, so let's go back here, present. OK, so this actually doesn't capture all your objects on the heap. That's why this can be fast for production. Right? So you can actually do this, like gather these snapshots every 10 minutes or 20 minutes, and this wouldn't slow things down substantially. It takes a representative sample of your heap, which what that means is that it uses a Poisson process for sampling objects as they're being allocated. So on average, it takes one sample every 512 kilobytes. That's why it can be low overhead. But it does have some caveats. The caveats are that right now, anything that's inlined into the function, so if you have a function and you inline lots of things into it, allocation will be attributed to the function, like the containing function. So if you see app.get is hot, then you should really look at all the functions it calls synchronously, because allocation may actually be inside those. But that's something we are actively working on making better. And then there's some edge cases. The V8 optimizer is really smart, and it optimizes things quite a bit. So there's some types of allocations that it cannot observe. But it's already pretty good to use, and I would definitely welcome feedback on this. All right, so let me quickly cover native leaks. Sooner or later, I mean, if you're writing native modules, you probably care about this. Or if you work on Node core, you care about this. But let's say you have an app and it uses some components that are native. How can you debug them? Well, you can use Valgrind. But the challenge I have with Valgrind is that, again, it's not the best for production because it slows down your application quite a bit. So guess what? There's a sampling heap profiler, the same thing I showed you, available for native code as well. There's a tcmalloc native allocator that has the same feature. In fact, that was the inspiration. That's the thing we use for production services at Google. That's how we debug memory leaks at Google for all the things we run in production. And that was the motivation behind why we added sampling heap profiler to V8. So yeah, so there's some links there that tell you how to do it. I won't go into too much detail about that but it basically gives you the same kind of output. But one thing I will maybe try to inspire some people here, that it seems like we have a sampling profiler for JavaScript, another one for native code. Wouldn't it be nice if somebody wrote a module that basically gave you a consolidated view of all possible leaks? So if anybody wants to go write that would be awesome. So the slides are right there. Memory usage, I mentioned already, that gives you a plot of memory usage of your application. Yang, in the previous talk, showed you that there is a new module inspector that's built into Node core that can give you access to the JavaScript API for inspector. All of these tools that I showed you, all the snapshots, allocation profiler, and the sampling heap profiler, are available through that. So you can just write JavaScript code and get all of this functional. So that's all there. Heap dump and heap profile. I just noticed that there was no NPM module for heap profile. So I just published this, I think, earlier today. So brand new. And if you really want to do low-level memory debugging, LLNode and MDB are also good. There's a talk link at the bottom, debugging issues in production. It's by Yunong from Netflix. It's a really great talk. It talks about the considerations for using tools in production and how you can debug memory leaks in production. I definitely recommend checking that out. So the thing you should walk away with is leaks are going to happen, right? So what's the message I want you to take away? That there are tools available. Try them out, because you want to be prepared when the leak happens in production. And you don't want to be using these tools for the first time when you actually have a production service that's actually leaking memory. So try these out, give them feedback. So I'll be at the Google Cloud Platform booth. So if anybody has questions, I can answer questions there. And actually, we have a really awesome demo for debugging in production that we can show you once you drop by. All right, that's it.